Yeah, might as well. Good thing. What do you have in the bag? Hi, I'm Tom Laskowski, Director of Midwest Native Skills.
And I'm Glenn Monaghan. Welcome to Fire Volume 2, our second video on making fire without matches.
In Fire Volume 1, we taught you how to make fire using the three most widely known primitive methods for matchless fires: flint and steel, the bow drill, and the hand drill. In this video, we'll show you over 40 less known ways to make fire, including the fire piston, improvised reflectors, and various chemical methods. We'll also show you how to use such unlikely materials as water, ice, or even Jell-O.
Our ancestors displayed amazing ingenuity and inventiveness in making fire using the materials and conditions that were readily available to them. For example, people in dry deserts could use the fire plow, taking advantage of the unique plants that were available in that area. We will continue that tradition of innovation and show you how to make fire using things that are available in today's modern society, such as 9-volt radio batteries, a flashlight, or common chemicals found under the hood of your car. But first, here are some additional tips and tricks that you can use with flint and steel, the bow drill, and the hand drill. Hey.
Until you're comfortable with your fire making skills, a good general tip is to use your first flame to light a candle. This way you can use the wax from the candle to drip on your fire lay to help nurture your fire. And if your fire goes out for any reason, you can use this flame to help relight your fire lay. Even better than a regular candle, you can use a magic relighting birthday cake candle. This way, if the wind blows the candle flame out, it automatically relights.
Hey. Say.
If you're having trouble getting a fire with flint and steel, you may want to try to use a striker made from a tempered high carbon steel. Even though they may look the same, the striker made from the high carbon steel will produce bigger and hotter sparks than the sparks produced from a low carbon steel. One way to test the carbon content of a piece of steel is to place it against a grinding wheel and observe the sparks. High carbon steel produces showers of sparks with ends that burst into bushy stars. Low carbon steel produces mostly straight sparks. The few bursts you may notice will be much smaller. In this side-by-side comparison of the spark test, you can easily see the difference in the sparks made with high carbon and low carbon steel. And a properly tempered high carbon steel will make better sparks than a steel that is too hard or too soft. An Allen wrench is a good example of a high carbon steel that is not properly tempered for flint and steel fire making. To temper this steel, carefully heat it to a cherry red color, and then quench it by quickly dipping it in water. This will improve the steel's ability to produce sparks with your flint. Most carbon steels can produce enough sparks to make a fire, but the bigger the sparks and the more of them there are, the easier it'll be to catch one in your char cloth.
Hey, what do you know?
Speaking of char cloth, we said that any type of 100% cotton will work to make char cloth, but frayed cotton like this seems to almost reach out and grab the sparks from your steel. This type of cotton is my first choice.
Huh.
Since getting the sparks onto the char cloth can be tricky, here's a tip I sometimes use to help catch a spark. Fold your char cloth over the flint before you strike it. This will put the char cloth right where the sparks are made when the flint and steel are struck together. To use this setup, hold the flint still and strike down with the steel. The steel actually cuts through the char cloth and creates the spark right at that spot. A tip you can use to replace your char cloth is to make a char tube. A char tube is simply a piece of metal tubing with cotton cord or wick threaded through it. One end of the cotton is charred to replace your char cloth. The other is used to retract the cotton into the char tube once done. Once the charred end catches a spark, place it in your tinder and then blow it into flames. Once you started your fire, you can retract the glowing end back into the char tube to extinguish it. You may need to cover the end with your finger to cut off the oxygen to ensure that the ember goes out. The nice thing about a char tube is that each time you use it, You make fresh char cloth for your next fire. After you've used your flint and steel for a while, you'll notice that your sharp edge has become rounded and dulled. To correct this, you can use a technique known as percussion flint knapping. To sharpen the edge using percussion flint knapping, hold the flint in one hand and strike sharply across the edge with your steel. This will leave a fresh, sharp edge on the flint that will produce better sparks from the steel.
Huh.
We showed you several ways to make char cloth outdoors, but some people prefer to make it at home. If you make it indoors, the smoke will soon start to fill up the room. To eliminate the smoke, you can force it to burn by purposely lighting the jet of smoke coming from the hole. The smoke won't ignite by itself, but when lighted, it will burn cleanly. When the flame goes out, the char cloth is done.
Hey.
We also have some additional tips for the bow drill.
Say.
You may have noticed that the bottom of your bow drill's spindle becomes rounded in use. The side grains at the center of the hole are softer than the end grains at the center of the spindle tip, so the middle of the hole wears away faster than the center of the spindle. At the outer edges of the hole in the spindle, the grains meet at right angles, and both the spindle and hole wear more rapidly and evenly. This creates the curved shape and produces most of the wood dust as the two pieces are ground together. If you draw a line out from the center of any spinning object, every point on that line turns around the center at the same number of revolutions per minute. However, points farther from the center cover more distance per turn than points closer to the center. Covering more distance in the same time means the outer points are moving faster than the inner points. The increasingly higher speed creates more heat as you go farther from the center. At the exact center, the speed is 0, so little heat is created there. This works against you with the bow drill because the center of the drill is creating drag that makes it harder to spin, but gives you very little heat to help produce a coal. So, one of the most effective tips is to hollow out the center of the bottom tip of your spindle. By removing the wood from the center, you are removing the drag so that all of your energy goes to spinning the outer parts of the spindle that are moving fast enough to help create heat. Also, flatten out the bottom of the spindle before each attempt to make fire. Because the hole in the hearth board is dished, flattening the bottom of the drill further enhances the effect of removing its core. All contact is then at the outer rim where the speed, and therefore the heat, is greatest.
Hey, what do you know?
An interesting variation on the bow drill is the Egyptian bow drill. This is particularly useful when your cordage isn't very strong. Instead of wrapping the cord tightly around the spindle to keep it from slipping in use, the middle of the cord is actually attached to the spindle. With the cord tied to the spindle, or through a hole bored in the middle of the spindle, the cord can't slip, so you don't need to have as strong of a cord as you'd otherwise need for a regular bow drill set. In order to make it work, you need to wind some slack cord around the spindle. As you bow, that wound up cord unwinds on one side of the knot, while the previously unwound cord from the other side of the knot is wound onto the spindle. This means you need to have a longer cord than normal, but again, it doesn't have to be nearly as good or strong as needed for a regular bow drill. Furthermore, since the cord is slack, you won't ever accidentally launch the drill if you slip, and the set will stay together all by itself when you put it down.
Say.
Conventional wisdom says to use a slightly curved bow stick. The curve on the stick helps the bow to flex and reduces shock on the cord, especially as you insert the spindle. However, if you have good strong cordage, a straight bow stick is actually easier to hold and control. And you don't have to worry that the spindle and the stick are going to interfere with one another when you're using a straight stick, because they actually are on opposite sides of the cord.
Huh.
A common and very realistic concern is how to get fire from wet wood, such as you might gather after it's rained, or if your bow drill set were to accidentally get wet. Well, to demonstrate how to deal with that, let's start off by soaking this wood in the stream for a little while. If your wood was dead and dry to begin with, even a torrential downpour or a 2-hour soaking won't wet the wood all the way to the core. So if you can, start with the large enough piece of wood that you can carve away the wet outer parts to get to the dry wood inside. But what about a finished set, like this one? First, the biggest concern is where the drill grinds against the fireboard, since this is where the heat and the dust are made. So, dry the wood as best you can, and then cut off enough of the drill tip to reach dry wood. Similarly, shave off the wettest top layer of the fireboard. The existing hole and notch gave water an easy path to soak deeper into the fireboard wood, so move to a new part of the board and start a new hole and notch. That way, you're going to drill into an area where the water hasn't penetrated so deeply. When burning in the hole, as soon as you have the drill seated, continue drilling, but back off on the pressure so that you're still creating heat and smoke, but little or no dust. Take a little break here. All that noise is the tip glazing over from moisture that's still in there. Stop and rest periodically, letting the residual heat evaporate moisture from the new hole. Pay attention to the appearance of the smoke and keep it up until you clearly see from the smoke that most of the remaining moisture has been driven off. Okay, it's looking about dry enough that we'll go ahead and carve our notch now. Then remove any glaze, core and flatten the tip of the drill, and make your coal.